Okay, hello. Now, if you successfully graduate from this bachelor program and from this very course, then I would expect you to be familiar with some of the important key terms and concepts about project management. And what are these key concepts or terms? Here they are. That's at least those that I think quite important for any kind of an industrial engineer. They should know about these things: work breakdown structure, work package, Gantt charts, and so on and so forth. So many of these, in fact, might be familiar to you, but yet, to be consistent among all of you, I'll very briefly introduce these terms, and then we'll see. Let's start with the VBS, work breakdown structure. Now, work breakdown structure, is a breakdown of a project into, it's a breakdown of a project into small pieces, smaller components, let's say. So these components are typically tasks, and the VBS, in short, work breakdown structure, is rather a deliverable-oriented or output-oriented thing. So it's not a process model, but it's a tree-like structure, and so that's hierarchical, in fact, in terms of structure. You typically determine your project main components by adopting a system implementation approach. Enterprise system implementation approach. I mentioned about these things for additional ones, or you go with a vendor-specific one, accelerated sub, Oracle unified method, and so on and so forth. Then you break down the main phases into some components based on your own needs. And the leaves of this tree, work breakdown structure, are called work packages. Okay? Now, work packages are quite important, quite key, because they have some critical attributes about the projects. These include, for instance, the planned start and end date, predecessor activities, that is, the activities that should have taken place or that should take place before this particular task. So we mainly plan at the work package detail, which are then aggregated on the project level, by the way. And in fact, usually we go back and reflect and update these values so that the project satisfy the generic budget and duration and scope constraints. Now, we have resource requirements. For instance, in IS projects, we mainly talk about human resources, and in terms of roles, mainly, like, for this particular work package, we need 2 analysts, 2 technical team members, and 1 consultant working 50%, and so on and so forth. That thing, 50% thing, is rather important. We also specify the rate that these resources will be allocated for this task. So that is whether the project manager, for instance, will be working 100% of his or her time in this particular task, or less than 100%. If you know how long a specific activity is planned to take, if we have also planned the resources, then we can already know the planned effort and the planned cost, in fact, in many cases, because it's very human resource oriented planning that we're doing. We're not using, in many cases, you're not using raw material or something. So that's it. That is for the planning phase. And there's also for the monitoring perspective. There we also need the actual numbers, so that we can see if the actuals are aligned with the planned ones. So the actuals are mainly for the start and end date, effort and cost values. These numbers are typically come from they typically come from the timesheets that people, resources, post at a certain interval, like weekly timesheets or sometimes monthly timesheets you post, and then we calculate the actual values and then see whether we are doing really all right with respect to the plan. Okay, now here is an example work breakdown structure, it lists the activities and so on, and of course it's a hierarchical structure, it's a tree-like structure, and the outputs that are expected are also listed here, as you can see. So another important term is a Gantt chart, and in this particular figure, or let me make myself invisible. In this particular one, the Gantt chart shows the sequence of activities in a timeline period. So, I mean, on one side it's something like a work breakdown structure, and the Gantt chart supporting it, showing the sequences of activities, in fact reflecting what the work breakdown structure has. So you will so in fact this Gantt chart simply shows the thing that we discussed that I put on the previous slide. Here you see the work breakdown structure with more attributes shown. Again, start and finish times, and the duration is in fact the start and finish times, and the duration is automatically calculated if you have the start and end time. Obviously it can do that. And predecessor activities resources are also here. One of the common deliverables are also important attributes that we need to kind of think about and define in any kind of a project plan. Now, another important concept or set of concepts. First one, activity network diagram, which also helps us to compute two other important concepts, critical path and float or slack. Now, the best way to show what these concepts are is to go through an example. Now, the table here on that side shows the tasks, the planned duration for each task, and the preceding tasks for each project activity or task. So the question is, what is the critical path? I mean, the sequence of activities that cannot be delayed without delaying the project completion date. That's the official definition of critical path. The second question is about the slack or float, if you like. And in fact, the float or slack again is the amount of time that a task can be delayed without causing a delay in the project completion date. I mean, kind of a buffer, if you like. So based on the information in the table, you can build an activity network diagram. And that activity network diagram can look like this. And based on the duration of these tasks and the precedence relationship between different tasks, you can calculate the critical path. So I will not do the calculation right now for the sake of simplicity, in fact for the sake of timing for this video, and I'm pretty much sure in fact you can do it in your own time. Just a hint, it's essentially the longest path here in the network in terms of the duration. Now I can at least at this stage already tell you that the longest path in this network is BAF. Okay, let me show you. BAFGH. Now, the discussion of slack or float is rather different in the sense that you can't simply deduce it only by looking at this graph. You need to do some calculations. The question was, what is the slack for G, activity G, and E in this case? In fact, the slack for G is very simple. The slack for any activity that is in the critical path is very simple because there's no slack for those activities. So slack for G is basically 0, and for E is, it's a little bit, you need to calculate it, but for E I can tell you that it's 1. I mean, slack one day basically means we can still start doing the activities. We can start the activity 1 day later than the original plan or planned date, or we can be a bit lazy. In fact, we can prolong this duration for another day and we would still be fine because it will not influence the entire project duration. That's what we are concerned with, in fact, in the Slack discussion. Okay. All right. I mean, these were some important concepts about project planning and general project management, and I think all industrial engineers should be aware of these things. That's a shame if you're not. So see you in another video then.